All right, so once again, just going back to this real quickly. On a 30, 60, 90, we said that the ratio is always 1, radical 3, 2. But we went for this radius and hypotenuse to be 1, so I divide by 2 everywhere. So now this is just 1 instead of 2. This is radical 3 over 2, this is 1/2. Okay, down here we had our 45, 45, 90. And what did it end up being? It's usually 1, 1, radical 2, but then what did we have to divide by? Radical 2, because we want this hypotenuse to be 1. Okay, Chloe, what's another name for 1 over radical 2? The same thing here. And then this is 1. Okay, so our whole goal now is to use these triangles to fill in this circle. We're going to start here where we always start. This is going to be 0 degrees or 360 degrees. In radians, we would call this 0 or 2 pi. This is a unit circle. Right here is the origin. Right here is the origin of 0, 0. If it's a unit circle, that means the radius must be 1. So this point right here is going to be over 1 in the x direction and up and down 0. So that point is 1, 0. This angle is going to be 30 degrees. Does anybody remember 30 degrees in radians? Pi over 6, good. Now, to figure out what this point would be, I look back at this triangle, this 30, 60, 90 triangle. If I were to put that triangle, if I could lift it up and put it right here, what would be the x value? What's the x value here? Here's the x value. It is radical 3 over 2. And then the y value, that means this side right here, looking back up here, what's that side going to be? 1/2. So that's what this point would be. Radical 3 over 2, comma 1/2. Let's go to our next angle. The next special angle we come to is 45 degrees. Do you remember what 45 degrees is in radians? Pi over 4. So I have to look at my 45 degree triangle. Again, the radius had to be 1. Don't draw this, but I'm just kind of showing you what we're doing here. We're thinking of that triangle as being right here. The radius had to be 1. This has to be 45, that's 45, that's 90. So this value here, if that is 1, this has to be the same as that. So it has to be radical 2 over 2. And the y value must be the same as this y value. So it's going to be radical 2 over 2. The next angle that we come to is 60 degrees. What is it, guys? Pi over 3. So now I have to take this triangle, but I have to rotate it around. I want to think of this. So if this is at 60 degrees here, see this is 60 degrees. Across from the 60 degrees is that radical 3 over 2. Is that an x or a y there of radical 3 over 2? It's a y value, isn't it? So y is going to be radical 3 over 2. This would be the 30 degree angle because 60 means how far we've rotated right here by the origin. So that's 30 degrees. So then this would have to be 1/2 in order to keep that hypotenuse at 1. So this is 1/2. And then right here, this would be a rotation of 90 degrees, which is pi over 2, and that point would be 0, 1. Your goal is to be able to fill in this entire unit circle. Next year in pre-calc, they're going to give you timed tests over that, where you have to be able to do it in maybe, I don't know what they'll give you, 10 minutes, 15 minutes maybe, and fill in the entire thing. So hopefully you kind of understand where it comes from. Once we know this, we can do a lot with this. I can now see that 0 degrees is the same thing as 0 radians. The sine of 0. Remember how sine is normally opposite over hypotenuse? Go back to this again, guys. SOHCAHTOA. We also know, though, that sine is y over r, and cosine is x over r, and tangent is y over x. But what's the radius always in this, guys? What do we say the radius always is? Just 1, right? So instead of thinking this as y over r, sine could just be thought of as y now. Just y. It's y over r, but r is 1. So it's just y. So what's cosine going to be? Normally it's x over r, but r is 1, so it could just be thought of as what? X. Tangent, we don't have any other option. It's still just going to be y over x. So now watch how I can use this. I go to my angle, 0 degrees, and I know that the sine at 0 is just going to be the y value. This is x, this is y. This is x, y, x, y, x, y. These are just points. So if I want to know the sine of 0, it's just going to be 0. If I want to know the cosine at 0, it's going to be 1. It's just the x value. If I want to know the tangent, it's going to be y over x, so it's just going to be 0. 30 degrees. I think 30 is 180 divided by 6, so it's pi over 6. That's the reason why. The sine is just going to be the y value right there. So I look at 30 degrees, the y value right there is 1/2. To find the cosine, it's just going to be the x value, radical 3 over 2. Now to do the tangent, this is a little bit trickier. I have to do y divided by x. Y divided by x. So if it's y divided by x, that's going to be 1/2 times 2 over radical 3. And so now the 2's cancel, and I get 1 over radical 3. And so I rationalize it, so this would be radical 3 over 3. I want you guys to see if you can finish it now on your own. I'm going to be slowly finishing the chart up here, but don't look. Try to do it on your own as much as you can. You may have had a little trouble here with tangent of 45, but what's anything divided by itself? If I have to do radical 2 over 2 divided by radical 2 over 2, what's that going to be? Just 1. Anything divided by itself is 1. Were you able to figure these out? Does everybody have questions on how I got anything there? All right, so now we're going to go around the unit circle. We're going to go to the second quadrant. This is another special angle. It's going to be 60 degrees away from 180. So what is it if it's 60 degrees away from 180? 120. I know 60 is pi over 3, so it has to be 2 pi over 3. This is going to be 45 degrees away from 180, so that's 135 degrees. 45 degree reference is pi over 4, and I know that it's 1, 2, 3 45s. My next angle is 30 degrees away from 180. That's going to put us at 150. 30 degrees is pi over 6, and I have to think 30 times 5 is 150, so it's 5 pi over 6. Down here it's 180 degrees, and that's just pi radians. So now I want to fill in these points. Well, 120 is going to be the same thing as 60. It's the same triangle. So it's still going to be 1/2 and radical 3 over 2. But what changes in that quadrant 2? This is quadrant 2 now. What's going to change as far as that point goes? Is this point in the positive? Go ahead, Chloe. Yeah, the x needs to be negative. For the 135, it's going to be the same thing as this. Still a 45-degree reference. But again, like we said, the x's are going to have to be negative in this quadrant. Y's are still positive. For 150, same thing. Radical 3 over 2, 1/2. X has to be negative though. And then this point, if our radius is 1, we're going out 1 in the x direction and up and down 0. Okay, I'm going to go ahead and do the angles in degrees and the points, but I'm going to have you do the radians this time. So 30 degrees away is going to be 210. Still a 30-degree reference, so the same as this, same triangle. But now what's going to happen as far as the signs go? They're both negative, aren't they? So this is quadrant 3. X and Y are negative. This is going to be 45 degrees past 180, 225. Same values as up here, because it's the same triangle that would fit in there. But they both have to be negative. This is going to be 60 degrees past 180. So same thing, but they're both going to be negative. And finally 270 degrees. And that's going to be over 0 and down 1. All right, so now I need you guys to tell me what 210 is. It's a 30-degree reference. Raise your hand if you can tell me. Go ahead. McKenna. Oh gosh. Long spring break. I like blanked out there. 7 pi over 6. Okay, 225. Audrey? 5 pi over 4. Right. 240, that's a 60-degree reference. Yep. What is it, Ben? Right. And then what about 270? Go ahead, Ben. Say it again? Okay, reduce that. 9 over 6 is close. 3 pi over 2. That's interesting. Why were you thinking of it as 9 pi over 6? Oh, okay. Yeah, that's fine, but couldn't you also think of it as 390 degrees? Yeah, that'd be a little easier, wouldn't it? All right, very good. Okay, so now I will do the radians, and I'll have you guys, well, that's kind of hard to do it that way. Let's just do it together. What's this one going to be, guys, in degrees, everybody? It's going to be 300. What's this one? 315. What's this one? Good. Okay, so we're going to have the same as 30 here. Is anything negative in this quadrant? Just our y's, right? Okay. And do we know these 300 degrees in radians? It's a 60-degree reference, so we have to think of it as 60's pi over 3. What is it? 5 pi over 3, good. 315 is 45 degrees away. That's pi over 4. What is it? 7, good. This is 30 degrees, which is pi over 6. So what's it going to be? 11. Good job. All right, so that's our whole unit circle. Okay, it took us about 15 minutes, but you know, like I said, you guys will probably next year have to do it in about 10. They might give you 15, I don't know. But so how does this even help us? Well, let me give you your worksheet. Now, we already talked about how we can find the sine, cosine, and tangent using this. But now we're going to look at how we can solve problems going in the other direction. I'm going to do a couple problems off the worksheet with you. All right, so let's just take a look at, for example, let's do number 12. Okay, so for number 12, it's asking us to do the cotangent of 4 pi over 3. Cotangent, I know, is the reciprocal of tangent. So I know cotangent is going to have to be x divided by y. So I'm going to have to look at my unit circle. I'm going to have to go to 4 pi over 3. Right here it is. And I'm just going to look at my x, and I'm going to look at my y. So I'm going to, the x right there is negative 1/2, and I have to divide that by the y value, which is radical 3 over 2. And so if I have to do this, I'm going to multiply by the reciprocal, and I get negative, these 2's can cancel, so I have negative 1 over radical 3. I can rationalize that, and I get negative radical 3 over 3 for that answer. Yes? Is it in that? 4 pi over 3. Oh, yeah, I didn't see my negative there. Thank you. Yes, that is a negative. So it's going to be positive radical 3 over 3. Yeah, make sure you can see those. Mine are a little hard to see when it's a radical. They're there. Okay, so you guys on your own now, let's have you do, let's do tangent at 330 on your own. Number 10. That one's the negative radical 3 over 3. Got that? Okay, what about down here then? So we used to draw pictures, right, to do any of these kind of problems. Well, now we're not going to have to do that. Let's look at number 18. How do I start this problem if I have a squared? What do I have to do to both sides? Take the square root. If I take the square root, what do I have to put in front? Plus or minus radical 3. This is tangent. So I have to think of y has to be plus or minus radical 3, and x would have to just be 1. But remember, it could really be plus or minus radical 3 over 2 and 1/2, right? Because wouldn't they cancel out? Those 2's on the bottom would go away. So I'm trying to look at my unit circle and find where is it that y, really I'm thinking of this like this. It's plus or minus radical 3 over 2 and 1/2. See, whenever this happens with these radical 3's on tangent, I know that it can't just be radical 3. Nowhere on the unit circle is y just radical 3. But there are lots of places where y is radical 3 over 2 and x is 1/2. And that would be equivalent to this. So I've got to look at everywhere where y is plus or minus radical 3 over 2 is what I'm looking for. So it's here, 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 oops, you can't see that, and here. So all those places. So that's going to be theta could equal 60 degrees, 120 degrees, 240 degrees, or 300 degrees. Questions on how I got that? All right, let's flip on the back now. So see, now we don't have to draw pictures. We're just going to use this unit circle. So on the back. All right, let's do number 23. What do we do on a problem like 23? What do I have to factor out? Tangent. So I factor out a tangent, and I'm left with tangent theta minus 1. So now I have to set tangent theta equal to 0, and tangent theta minus 1 equal to 0. Then I have to think, what is tangent? Well, tangent's y over x. Add 1 here. Tangent is 1, y over x. So I'm going to look at my unit circle. I want to see anywhere that y is 0. So looking at my unit circle, there's y is 0. There's y is 0. So only at those two spots is y equal to 0. Look back at the directions. This is saying that our answer has to be between 0 and up to 2 pi, but not including 2 pi. So what's the answer going to be then for this part? Am I going to use 0 or am I going to use 2 pi for that first one? 0, right? I can't call it 2 pi. So my first answer is 0. Another place, though, where y equaled 0 was right here. And that's at pi. See, we're using radians, so make sure you don't use 180. You want to use pi. And then what are we going to do for this? Where tangent has to be 1, so x and y both have to be 1. There's nowhere where x and y are both 1. Any ideas? Yeah, what can we do, Lucy?
Where x and y are both relative to.
Right. See, if x and y are just the same thing, they would reduce to be 1, wouldn't they? So it's going to be right here. So what's that answer going to be then? Not 45, because we're doing radians. Pi over 4. And then, is there any other place where x and y are exactly the same? 5 pi over 4. Very good. All right. We're going to do one more, number 26. So 26 is a little bit different. See how on this one it was set equal to 0, so we factored out a tangent? Here's what I see people do. They're like, oh, okay, I'm going to factor out a cosine. Nope, can't do that. If we don't have it equal to 0, if it's equal to any other number, we have to subtract this over and factor. So I'm going to have to subtract 1. So I have 2 cosine squared theta minus cosine theta minus 1 equals 0. Now we have to set up our double parentheses to factor. 2 cosine theta times cosine theta would equal 2 cosine squared theta. Now I look here, 1 and 1. My outers give us a 2 cosine theta. Our inners give us a 1 cosine theta. We want to get a negative cosine theta. So we have to think, how do the signs go? Ando? You are correct. That would make it work out correctly. So that's factored correctly. So now I have to set this equal to 0 and that equal to 0. So solving this one, I'm going to get cosine theta equals negative 1/2. Solving this one, cosine theta equals 1. So we have to think, what is cosine? Is it x, y, r? What is it? Just x now, right? So I'm just looking, where is x? Negative 1/2. So we go back to our unit circle. We're going to look, where is x? Negative 1/2. What are our two answers going to be? I got it? Go ahead. Go ahead, Ben. What did you say? What was your first one? I think you said it, I just couldn't hear you. Not pi over 3 though, we want x to be a negative 1/2. So x is a positive 1/2 here at pi over 3. We want it to be a negative 1/2. So what's it going to be? 2 pi over 3. And what was your other one? Right. And then looking at this, where x is 1, that's just right here that x is 1. So that's just going to be at 0. Okay? Questions on anything? All right, so I want you to use your unit circle. You can draw triangles if you want, but I'd prefer you try using the unit circle a little bit. If you get stuck on something, then you might want to go back and use your triangles that we did before break. Okay? Good job.